Hello friends, this video on motion part 1 is brought to you by V-Guide Physics. Motion. In this video, I am going to discuss the topics distance and displacement, speed and velocity and different graphs. See here the motion. What is meant by motion? Before that, we should come to a term called rest. What is rest for physics? The position of the body is not changing with respect to its surroundings is termed as rest. So if you see an object, that object is not changing with respect to its surroundings, we can call that as rest. But if the position of the body is changing with respect to its surroundings, we call by the term motion. So, a body is at rest or motion, it depends on its surroundings. Before going to the other physical quantities, I am going to classify the physical quantities into two major classification, means scalar quantities and vector quantities. Most of the terms in physics are categorized into two main quantities called scalar and vector. The physical quantities which requires only magnitude is termed as scalar. For example, when we tell about the mass, it may be 2 kg, 3 kg, like that only, right? We are specifying its magnitude. For distance, 10 meter, 20 meter, like that, we are specifying only the magnitude. But there are certain quantities in physics so that we need both magnitude as well as direction. For example, displacement, velocity, force, these all quantities, not only magnitude, you have to mention the direction also. So those physical quantities we can call by a name vector quantities. So all the physical quantities we can classify in these two categories. Few will go under scalar quantities, the other will go under vector quantities. So, first we are explaining about distance. What is the meaning of distance according to physics? Distance means it is the total path traveled by the body. Now I am telling the definition. I'll come to the case. So, it is nothing but you have to calculate the total path traveled by the body is called distance. And it is measured, its SI unit is in meter. And it is a scalar quantity. But there is one more quantity called displacement. It is nothing but the shortest distance between initial point and final point. Its SI unit is meter only. But it is a vector quantity. Then, if you see about the distance and displacement, the distance is always positive. But, see, the distance cannot be negative. See, displacement I told, but this is about the distance. Distance cannot be negative. The meaning is displacement can be negative. The displacement can be equal to distance or it is lesser than distance. So I can tell here the distance is always positive. But displacement can be positive, it can be negative and also it can be zero. Displacement can be positive, displacement can be negative or it can be even zero also. So, there is a condition that displacement can be equal to distance or it should be less. I am going for an example. So, here I am again telling, see, this is the distance. I am talking about the distance cannot be negative, but the displacement can be negative. See an example, a body start from A and it comes back to A. The body starts from A and it is going like this and it is coming back to A. I need to calculate what is distance and displacement here. See, the body's initial point and final point are same. Going here and coming back to the same point, so displacement is 0 because there is no distance between initial point and final point. But the distance is nothing but the total distance. Total distance is 2 pi r because it is a circular path of radius 10 meter. So circumference is 2 pi r. So it is 2 pi into 10, that is 20 pi meter. This is the answer. We will go for few more examples. See, a body starts from A and it reaches B. It goes a semicircular path of radius 5 meter. What is the distance? It is half of the circle, so it is pi r. Displacement is nothing but shortest distance, so it is 2r. So it is 10 meter. So distance is 5 pi meter and displacement is nothing but 2r because this distance is nothing but the diameter. See the third case. A body is coming like this for a 4 meter and it is going to be 3 meter. What is the distance? Distance will be equal to 4 plus 3, that is equal to 7 meter. 4 plus 3, that is equal to 7 meter. What about the displacement? If you see the displacement, it is root over 3 square plus 4 square, that is equal to root 25, that is equal to 5 meter. If you see this case, why this is root 5? I think you all understood. It is nothing but this shortest distance. But if you see this case, a body goes like this from A to this point, coming back like this, going to this point, reaches B. Total distance is 20 plus 8 plus 10, that is 28. From here to here, the shortest distance is nothing but 8. So, from this, I want to tell that distance is nothing but the total path traveled by the body, whereas displacement is the shortest distance between initial point and final point. But the basic difference is distance is a scalar quantity, displacement is a vector quantity. Now I am going for the next physical quantity called speed and velocity. In simple form we are doing, speed is nothing but we can understand how the motion is going on. We can understand that with the help of a term called speed. So speed is distance traveled by time taken. So its SI unit is meter per second. This also it's a scalar quantity. Velocity means displacement divided by time. Its SI unit also meter per second. It is a vector quantity. Then, if the body moves with a different speed or like a different distances in different time, we can't tell it's like moving with a constant speed or moving with such a particular velocity or a speed. So in those cases, we calculate what is the average speed. Same like we used to calculate what's the average mass for understanding the performance of a student. Same like how the motion goes. If the body is moving with the different speeds and all, we used to calculate average speed. That is nothing but total distance divided by the total time taken. Whereas average velocity is total displacement by total time. So in simple form, in shortcut form, I have written only in the form of equation. If you want to tell a definition for that, simple velocity is nothing but rate of change of displacement. Speed is nothing but rate of change of distance. Average speed is nothing but the ratio of the total distance to total time. Average velocity is the ratio of total displacement by total time taken. Here also we can tell in the terms of as scalar and vector quantities, units are remaining same. I want to do one question related to average speed. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. See, in this question, they gave two distance 16 meter, 4 seconds, 2 seconds. So I am going to calculate the equation. Average speed is total distance by total time. What are the total distance here? 16 and 16, 16 plus 16. Time taken 4 seconds and 2 seconds, 4 plus 2. So it is 32 by 6, that is 5.33 meter per second. Sorry, 5.33 meter per second, not square. Now, come to the next case. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find average speed and average velocity. Usha is swimming a pool and 90 meter is the distance going there and coming back. So I need to calculate what is the total distance for calculating average speed. It's going like this and it is coming back. So total distance is 90 plus 90, 180. Time taken, they gave 1 minute. 1 minute is 60 seconds. So 180 by 60, that is 3 meter per second. If you want average velocity, it is total distance by total time. So it is 0. So total displacement by total time. Displacement, initial point and final points are same. So there is no displacement. 0 by 60, that is 0 meter per second. Don't forget, average speed unit is meter per second. Average velocity also unit will be meter per second. Now I am going to discuss few graphs. So see, as the body is moving with a different speed, it means that we are giving acceleration for a body. It means the speed is not constant. The speed can be increasing or speed may be decreasing. So if the speed is increasing, we call by the name acceleration. That means rate of change of speed or rate of change of velocity. We call by the name acceleration. If it's a positive value, we call by a name acceleration. But if it's a negative value, we call it as a retardation. See here, total 5 graphs are drawn here. All the graphs, x-axis represents time, y-axis represents s. S means it is the representation for displacement. Therefore, this graph can be called as displacement time graph. Now, I am going to discuss about the inference from the graph. First graph, if you see, as the time increases, S is not changing. S is same. The meaning is the body is not at all moving or body is at rest. The body is at rest. It is for a stationary body. Second graph, if you see, as the time increases, displacement increases. And it goes in a straight line means you remember the body is moving under uniform motion. It means if you take any 2 points, if you take this point and this point, or you take this point and another point, if you take the slope of the graph, what? Slope. If you take the slope of the graph means, what is the meaning of slope? Slope is nothing but we have to take y2 minus y1 by x2 minus x1. So you see, if you take the slope from the point A to B, you can just mark it x-axis, y-axis. Take x-axis, y-axis. If you take it like this, it remains constant for any 2 points in the line. That is the reason we call by the name, this is the case in which body moves with constant velocity. So you see in S and T, there is no velocity term. But I am telling it's a constant velocity because if you take the slope, it means y-axis by x-axis. That means displacement by time. What is displacement by time? Velocity. So with that velocity, I understood in this case the body moves with constant velocity. But if you see these two graphs, In this graph, if you draw the tangent at each and every point, the tangent is getting increased. If you see the tangent, you see marking the tangent, that angle is getting increased. So it means that this is the case in which body moves under constant acceleration. But if you draw a slope of this part, the slope is getting decreased. It means that is a case in which body moves under constant retardation. Retardation means opposite of acceleration, decreasing. Speed is decreasing with respect to time. This graph, last graph, is similar to a second graph, but only one thing, it's coming down. It means that the body moves with negative velocity. So in short, what are the graph we did? We did only about displacement time graph, 5 special cases. Body at rest, body moves with constant positive velocity, body moves with constant acceleration, body moves with constant retardation, body moves with negative velocity. So these are displacement time graph, and I told a main thing why I told a constant velocity, because in this graph any 2 points if you are taking the slope, what is meant by slope? Y-axis delta y by delta x, or y2 minus y1 by x2 minus x1. You take this difference of this value by difference of this one, we get a constant value only. That is the reason why we are telling the body moves with a constant velocity. Look at the next graph, velocity time graph. In this graph, you see straight line. Here it is a straight line going like this. In the first case, we can tell that as the time increases, velocity is not increasing. It means that body moves with constant velocity. The velocity is not changing. So first graph is for body moves with constant velocity. Second graph means same like the previous graph. I can tell that if you take the slope of this graph, 2 points, if you take the slope, that value will remain constant. Okay, so I'm just taking this one. This is V1, this is V2, this time as T1, this time as T2. So if you take the slope, what is slope? Slope is nothing but y2 minus y1 by x2 minus x1. That is nothing but v2 minus v1 by t2 minus t1. Okay, this is called by a term acceleration. So remember, I am introducing the term called acceleration. Rate of change of velocity is termed as acceleration. So this graph is for body moves under constant acceleration. See this graph, next graph. That is an acceleration time graph. So in this graph, here acceleration is constant. So I can tell that body moves under constant acceleration. In short, I can tell that graph can be of different axes. It means x-axis and y-axis is changing. According to that, the graph inference also change. Here I already discussed with you 3 different types of graph. Displacement time graph, velocity time graph, acceleration time graph. And inference, all the inference also I told you. I need to tell one more inference. If you take the velocity time graph, if you calculate area of this graph, you assume area of this part. Okay, I am taking this part, easy to understand. If I take the area of this part, what is area? What is called area? Area is velocity into time, right? Here, because it is in the form of a rectangle, so if you take area, it is velocity into time. Can you tell me what is velocity into time? It is nothing but displacement. So that is another main inference. Area of velocity time graph gives displacement. Area of velocity time graph gives displacement. Can you take for this area of acceleration time graph? What is acceleration time graph area will give? area of acceleration time graph, I will get it as acceleration into time. What is acceleration into time? Acceleration into time is nothing but change in velocity from the previous equation what I wrote. Here I wrote v2 minus v1 by t2 minus t1 is acceleration. So if it is acceleration into time, it will be v2 minus v1. So here we got a very important conclusion. From the first graph, I told here you can take the slope. If you take the slope, this I can take S1, S2, T1, T2. So if you take the slope, it is S2 minus S1 by T2 minus T1. That is nothing but the velocity I told you, because rate of change of displacement is nothing but velocity. Now I am going to conclude it. In the next graph I told, here also if you take the slope, here also if you take the slope, we get acceleration. If you take the area, we get the displacement I told. But if you go for acceleration time graph, its area gives change in velocity. So now I am going to conclude. This is the main thing you have to remember. Slope of displacement time graph gives velocity. Slope of velocity time graph gives acceleration. Area of velocity time graph gives displacement, whereas area of acceleration time graph gives change in velocity. This is the 4 main points from this chapter. So you can calculate slope, you can calculate area. Slope of displacement time graph, slope of velocity time graph. We get 2 other physical quantity. You can calculate area of velocity time graph as well as area of acceleration time graph. Now this is my shortcut. Okay. Wherever let the mass slope, you do y-axis by x-axis. Wherever ask them area, you do multiply y and x. You take the product. It means slope means you take division. Area means you take multiplication. Slope means you do division of y and x. But area means you have to take multiplication, multiply y and x. So this is the shortcut to remember. So I hope you all understood what I meant. So displacement time graph, velocity time graph, acceleration time graph, we are calculating slope and area. From this we understood we can calculate even velocity and acceleration from a graph. We can calculate the displacement also from a graph. Thank you. Subscribe and share the videos of class 1 to class 12 for boards, foundation, NEET and JEE. Team V Guide Physics.